Hello, Replaying Japan. My name is Nathan Altice, and today Jared Pettitt and I want to present some of our preliminary work on agent-based Sugoroku analysis with a web application that we call Double Sixes. For those that aren't familiar, Sugoroku, whose literal translation is where we get our application's name from, is a centuries-old form of Japanese board game wherein players roll a pair of dice to move their pawns from start to finish as quickly as possible. The game's earliest form, Bon Sugoroku or Board Sugoroku, resembled abstract race games similar to backgammon. But the advent of block printing in Japan transformed the game into a highly pictorial form called Picture Sugoroku. Each Sugoroku board comprises a dozen or more illustrated spaces, with text informing the player of their next move, and sometimes a small bit of description about the illustration that's in the space. And Sugoroku could feature nearly any content or subject matter. It could be about travel, history, ghost stories, religious lessons, or even, as in this case, an advertisement for fire insurance. While Sugoroku games are prevalent in Japanese culture, they are largely unknown outside Japan, due in part to their waning popularity over recent decades, their scarcity outside of Japan, and the language barrier that limits their accessibility. Yet, Sugoroku as a formal model structures thousands of Japanese board games developed across multiple centuries, like this example from Bandai's Party Joy series in the 1980s. To date, most scholarship on Sugoroku treats them as visual works, focusing on their subjects and themes rather than the rather interesting structures that drive them. And this is due in part to a lack of tools to help analyze Sugoroku's formal properties systematically and at scale, because annotations like you see here from a museum exhibition book from the 1990s are pretty time-consuming, and then doesn't really show you a lot about the ways that the board spaces connect to one another. Double Sixes is an online application designed to annotate and analyze Sugoroku. Users can upload images, input metadata, such as the dimensions, the material it's made out of, the artist, the theme. They can transcribe and translate the text and draw connections between the spaces. But in lieu of describing its features, I'll now hand off to Double Six's co-designer and developer, Jared Pettitt, for a demonstration.
My name is Jared Pettitt, and I'll be showing you our web application, Double Sixes. So Double Sixes is built primarily using Vue, Bootstrap Vue, as well as Fabric.js. And I'll give you a little overview of the interface. So on the left side, we have a toolbar with a list of tools. And on the right side, we have our image upload button, which is how we start every annotation. So let's start by uploading this image that you've seen already. And over here, we have a sidebar button. And if nothing is selected, this will show us the board. So we can use this to annotate the board. World's #1 Sugoroku. And we can add all the metadata that we want here, different movement types, materials, etc. So from there, what we'll generally start doing is we will start using these tools to annotate some spaces. So I'll draw a couple spaces here. I'll add this one and this one. I'll add space 2 here. And I will add the agari, the ending space. So now what we're going to do is let's select one of these and open up the sidebar. And you can see that the sidebar has the space that we have selected. So I'm going to set that as the furidashi. And I'm going to select the end space and set it as the agari. All right. And while we're in this space sidebar, we can put, again, whatever metadata that we want, text, translations, and I will close this. So from here, what we do is we're going to add connections. And in Double Sixes, there are two types of connections. There are sequential connections and jumping connections. Sugoroku boards are typically either or. So in this case, I'm going to use a sequential connection, which is red, to connect the start to the space next to it, and then that space to the space next to it. And what a sequential connection says is that if you roll, so let's say you're on this furidashi. If you roll 1, you're going to go here. If you roll 2, you're going to go here. If I had annotated more of these, right, you roll a 3, you go here. It's like that. Whereas a jumping connection, which in double sixes is yellow, implies like a special case. So a jumping connection will be like, if you rolled a 5, go to space 12. So we can open up the sidebar while we have this jumping connection selected, and we can change it to a sequential connection if we want. But let's change it back to jumping. And let's say that in this jumping connection, if we roll a 6, then the player goes straight from the furidashi to the agari, which is not how this board works, but that's just what we're doing. We can add another chance. So we could say, or if it's under, I don't know, 3. So now if the player rolls a 1 or a 2 or a 6, they're going to go here. And we could add as many of these chances as we want. We can remove them. Yeah. So now that we've done a little bit of annotation, we can download a JSON object that will describe all of the annotation work that we've done. And we do that by pressing the download button here. All right, so here you can see, here's all the work we've done. We can do whatever we want with this JSON file. We can analyze it elsewhere, or we can also upload JSON files. We can upload our saved work. So I will upload a more completed version of that same board. So world number 1s, I'll zoom out a little bit. Let's upload that, yes. Cool. So here you can see this is a more completed annotation of the board. It goes from start to end. There's the agari, there's the furidashi. So now that we have the board uploaded, we can start doing analysis. I will open this analysis sidebar. And the first thing that you see is this list of preconditions. So if we have a board that doesn't make sense, that can't be completed, or that has conflicting rules, double sixes will let us know, and we can go fix that. Let's put those away. And here we have agent-based analysis. So double sixes implements agent-based modeling, which is an artificial intelligence technique that uses autonomous AI agents, like players in this case, to model systems. In this case, the system of a Sugoroku board. So by tracking agents' movements and interactions through the system, double sixes can be used to analyze board structures and can be used to play the game thousands of times. So the data that we capture with this can help identify play patterns, design motifs, player outcomes, etc., both within an individual board as well as like across genres, designers, time periods, etc. We can do whatever analysis we want with all of this data that we're about to create, right? So I'm going to go over here to the controls of the agent-based analysis. I'll set that we're playing it with 25 people for some reason. I don't know why. Typically, games in Sugoroku end on the round when a player reaches agari. We can turn that off if we want, but let's just keep it on, and I'll press play. So you can see the agents moving through the board here, and we can see that on the last round, 2 players reached agari, and there were 5 rounds until the game was over. As players move through, they add heat to the different spaces, which can be used to analyze like how often a space is on. You can see like nobody went to 1 here. If we were to do it again with more players, we would get slightly different but probably similar data. Double sixes also supports jumping Sugoroku, which I will show you now. So let's upload this game, Henshin game, and let's also upload a completed annotation of this game. All right, pretty complicated, but you can see that our agent-based modeling works just the same. This one's going to go a lot faster because there are a lot fewer spaces. Wow, that one took 11 rounds to complete. That's interesting. That's an outlier. And now that we've done that, we can also download a JSON file that describes the analysis that we've just done. So I'll press that, and that will save to our downloads folder. Double sixes is still in development. Our goal is to have this widely available as a web tool for anyone who wants to use it in the next year. We want to have a database that users can add completed annotations and images to that can support analyses of this form. And a potential long-term goal is to be able to model more complex Sugoroku games like Bondi-style Sugoroku games, for instance. Thank you very much.
Thank you, Jared. Our hope is for this project to satisfy three primary goals. First, to develop an extensible metadata scheme to formally describe Sugoroku, which we can then archive for a large online accessible database. Second, to analyze that metadata to look for design patterns and recurrent structures across hundreds of Sugoroku. And third, to make this tool accessible online for games researchers, historians, and students. So we look forward to making this tool publicly available for scholars and students within the next year. Thank you so much for your time.